Swayam Prabha. Digital India. Educated India.
Today we will be learning about additive manufacturing. Additive manufacturing is a new revolution in manufacturing. Driven by cutting-edge technologies and breakthrough innovations, additive manufacturing is reimagining production processes, redefining sustainable manufacturing. Additive manufacturing is currently more than 2.2 billion worldwide. And if you see the machine, there are a lot of machines which are being currently sold across US and globally. In India also, large number of machines are being sold by various companies. The data which I am having is from 2012. It is that time lower cost machine was 35,000 was sold, and in US and especially in other places, and US also the bigger machines were only 6,000. But now things have changed. Now what we have is with 20.50 CAGR, global additive manufacturing, it is supposed to be a worth of 34,846 million by 2028. So welcome to the world of additive manufacturing, which is transforming in India manufacturing process and worldwide manufacturing process in a very big way. It is opening a new pathways to economic, technical and logistic advantages in the manufacturing domain. Additive manufacturing takes less than 60% of the time and consumes 80% lesser energy. It is a huge departure from conventional manufacturing process, traditional process, that is both traditional and non-traditional processes. It is also environmental friendly because in normal manufacturing process it is a removal technique, right? So there is a block, you remove some portion of the block, and after removing whatever is there, that portion is basically a component. So we have to think what is exactly happening to this portion which is being removed. That is sometimes waste, sometimes we are recycling, sometimes we are doing other things, but that is going to that is a lot of energy required for recycling. Whereas in additive manufacturing things are very different. We are directly printing only those portions which are required as a component, and of course little bit of support material is also added. So while conventional and subtractive manufacturing process 3D object by machining out, additive manufacturing is popularly known as 3D printing. It is also known as 3D printing. It makes layer by layer manufacturing and builds product in a minutes, and also smaller sizes and bigger sizes components are also can be made using additive manufacturing. So very small at micro level printing is also possible, whereas even in civil systems, bigger projects using additive manufacturing is also possible. So additive manufacturing or rapid prototyping or 3D printing, it prints faster, significantly reduces time to market, very fast. Whenever you want to print something, you take it, make the CAD model, convert to STL file and give it to the computer, and from computer is going to give it to the 3D printing machine. So the time from design to manufacturing is very less, and this speed up the overall innovation. So new technology, new product, if you design, you don't have to wait for a long time to actually realize it. Very fast we can design and produce part and less time. So it is huge benefit, and it's sustainable also, resource consumption is less, and then cutting gas emissions are reduced, and applications are limitless. It is various models we can fabricate, and it has various applications in various industries. So whenever we see is adding up, it is a 34%, almost 34% of the US manufacturers already adopted additive manufacturing in their manufacturing plants and manufacturing systems. It is not required that we have to remove the traditional manufacturing process. Additive manufacturing process can replace some portions or some processes. However, it should be actually as an addition to the manufacturing technologies and the machines which a company is already having. So the added advantage which the companies can use it and make it use for multiple applications. So applications are diverse, from automobiles, energy, medicine, aerospace, so many applications. NASA has successfully used rocket injectors, and in a Formula car 3D manufactured product has also been used. A wide range of materials can be covered, which can be used for industrial application and also for other applications. Previously repair was a big problem because the component has to be taken out or it has to be replaced. But now with additive manufacturing process, the component need not be thrown out. It could be repaired easily. There are so many techniques which are available in additive manufacturing that can be used for repairing of components. So additive manufacturing is also known as 3D printing. It refers to a manufacturing process which creates 3D object using multiple layers of products to form a component. There are various methods are there for additive manufacturing, and various materials can also be used like glass, plastic, ceramics, metals. There are also other technologies like 3D printing, rapid prototyping, direct digital manufacturing, layered manufacturing, and additive fabrication. All of them have similar kind of terms which are being used to depict the additive manufacturing setup processes. As per standard, there are various additive manufacturing processes, but there are 7 major additive manufacturing processes which we are going to learn soon. And why this difference is in terms of building mechanisms, price point, materials, usage, there are so little bit of difference is there in all this. Actually, some of them are quite different with respect to each other. So in this image which you can see here, additive manufacturing machine is used to make a very intricate setup plastic components. So why additive manufacturing used? It is used for prototyping, it is used for low volume manufacturing, tooling. Tooling means previously, especially if you see that tooling of plastic bottles or anything which you want to make, dies are very expensive. You have to make 5-axis, 6-axis, 7-axis milling machine, CNC milling machine to make a die. And it takes a lot of time also. Now, many of the tooling can be done in additive manufacturing process, metal additive manufacturing process. And of course, post-processing is required, but that is much less time consuming compared to the post-processing or the total time required for manufacturing. Consumer products can also be made. Customization is very much possible with additive manufacturing because previously we used to have one design which is being made multiple times. Now, if additive manufacturing used, we can use the same, means every time we have to print. So you can customize it easily. Art production, AM can be used for art production also, and see how it looks. Design checking, you can make prototype and check whether the design is okay or not. But apart from the same prototype can be also analyzed. For education, AM is used. For medical, lot of applications are there, many places AM is used. So now categorization of additive manufacturing process. Here you see one image of metal additive manufacturing machine. So as for ASTM F42, additive manufacturing are classified into 7 major categories. The difference in this are basically material used, deposition techniques which is used in the machines, and the way the material is being fused or solidified. So what are the 7 additive manufacturing processes according to ASTM F42? One is photopolymerization, second is material jetting, third is binder jetting, fourth is material extrusion, fifth is powder based fusion, sixth is sheet lamination, seventh is direct energy deposition. Now we are going to learn more in depth. According to ASTM A42, there are 7 techniques, 7 processes basically. Let me take a different color. One is photopolymerization. In this, basically a vat of liquid photopolymer resin is cured through selective exposure of the light. Resin is cured selectively using light, laser, TC, etc. The next one is material jetting. Second one, in this material droplets are used. And then it is basically set using UV light. So here also photocurable resins are used. This is actually originally, this was termed as 3D printing. So there are names also, multiple names which are there for this photopolymerization. So some of the names are stereolithography, SLA. It is also called digital light processing. These are very similar technologies, but they are not same. They are a little different from each other. And then clip technology, that is continuous liquid interface production. Clip, that is also falling under this system. Then scan pin and selective photo cure. These are names are why, because these companies are making technologies which are falling under the main photopolymerization technique, and the name is different, and also some technology is also different. Like clip technology is much faster, little bit less accurate, but very fast. So this is falling under photopolymerization. Under material jetting, there are also various technologies. One is 3D printing. Multi-jet modeling. There are also drop on demand. Now we will go to the next technology, that is binder jetting. Third one. In this, the technology is that liquid binding agents are selectively applied on thin layers of powder material to build up layer by layer. That is liquid bonding agents are selectively applied into thin layer of powder material to build up processes layer by layer manufacturing. Layer by layer. So here electricity is not used because it's not required. So in this one, and materials can be organic, inorganic, it could be metal also, metal, ceramics, etc. The other names for this is drop on powder. DOP. Powder based printing. The next one is coming is material extrusion. In this, the material is extruded through a nozzle. And it is made into multiple layers. Engineering thermoplastics are used. So this is one of the most widely used technique for this one, and FDM is one of the machine, and various companies, they have actually made this machine and they are selling in the market in a very cheaper price. The technologies which are coming is fused deposition modeling, FDM, and fused filament fabrication. That is a the next one, that is powder waste fusion. Fifth one. In this, the technology is that powder material is selectively basically consolidated and they are being melted together using a heat source such as laser. So here powder So here this is widely used technique for especially for metal. The technologies which are coming under this one is selective heat sintering, direct metal laser sintering, electron beam melting, selective laser melting, SLM, and selective laser sintering. This is one of the widely popular name which you have, many of you may have heard about this. Sixth one is about sheet lamination. In this technique, sheets of materials are being stacked and laminated together to form the object, and it could be the method for sticking or making the object. It could be adhesive, ultrasonic welding, or even brazing. This could be using adhesive, it could be used ultrasonic, or brazing. So here the technologies which are under this is selective deposition lamination, that is SDL. Laminated object manufacturing, this many of you would have heard, one of the popular method. And ultrasonic additive manufacturing. The last one which we are discussing is the direct energy deposition. In this, basically powder metal or wire is being fed into the metal pool, which then generates a surface, and basically this is basically it is made into liquid format almost, and then the laser or electron beam is used. So the metal powder or wire is fed into a melt pool, and we are using laser or electron beam. Technologies under this one are laser metal deposition, electron beam free form fabrication, direct metal deposition, and laser engineered nest shape. So now we have seen all these 7 techniques and what are the other names which are being followed, which are there for this technique. Now we will see how the categorization can be done. So additive manufacturing process, it could be either liquid based, solid based, or powder based, right? So under liquid phase, it could be one is molten, and next possibility is polymerizable, if it is molten, It could be material extrusion, if it is polymerizable, one option is wet photopolymerization. Second possibility is the material jetting. If it is solid, then of course bonded objects. And as we have already learned, solid means sheet lamination. Now powder waste, it could be, one is melting, if it is melting, one could be powder waste fusion. The next possibility is the direct energy deposition. Or it could be binding also. If it is binding, then binder jetting. So now we have seen 7 technologies which are there, how this can be categorized with respect to each other. As far as materials are concerned, there are so many materials which are possible to be used in additive manufacturing. Some of the materials are metallic materials, that is we can use plain carbon steel, stainless steel, aluminum, copper, okay, then titanium, bronze, nickel, and various others. For polymers, that is plastics, we can use ABS, acrylbutyrene, nylon, polycarbonate, polypropylene, epoxides, glass-filled polyamide, winform, polyester, polystyrene. So many other materials can be used. There are also others which are not coming under this. Is we can use sand, we can use ceramics, we can use tungsten, we can use wax, we can use starch, we can use plaster, similarly. So many materials we can use. Biocompatible materials. There are various biocompatible materials which can be used. Some of the names I'll write. PCl, and there are several others also. So now we have to learn a little bit of the generic way of additive manufacturing. First is create CAD model. The next to convert the CAD model into STL file. Third one is slice the STL file into cross sections. Then construct the model by printing using a machine, and fifth one clean and finish post processing if required. So if I explain a little bit, first is you make a CAD model using any CAD software and then convert into .stl file, TDU lithography file. It is also standard test section library language, and .stl file is basically in computer CAD, and this is .stl file can be used to print 3D object, and this 3D object can be printed using the machine, and then this slicing. So if this is the object, it has to be sliced, and this slicing is generally done by the software which is already being given by the manufacturer of this machine. There are various reasons for it, like how the quality of the product, then accuracy and all these things depends upon this. So how much or how many cross sections you need to have, it depends upon some of the factors related to this machine. And then once we have this, so this once we have this one, the next one is we're going to print it, of course. So then orientation is of course important, and if support material is required, we need to add support material also. So then machine will be actually going to print, and then layer by layer the machine is going to print the product, and after that, once it is printing is done, maybe post processing is required because some marks will be there on the surface, the quality has to be improved, and these things are required for this. Thank you.